In this example, we are going to anti-differentiate tangent to the fourth power. Based upon the form of our integrand being just an even power of tangent with no secant term present. So the guidelines that we have for evaluating integrals of this form suggest that what we should do is apply this power reduction technique and then kind of algebraically expand and repeat as necessary. So let's see what that means. So an even power of tangent, so we're going to take two of them, so tangent squared, and pull them off. And this tangent squared term that we have pulled off, we are going to rewrite it in terms of its Pythagorean identity, so secant squared minus 1. And at this point, what we are going to do is take the tangent squared and go ahead and distribute it through, and then repeat this technique as necessary. So the first term is going to work out very nicely. We're going to have a tangent squared times secant squared. And we're going to be able to perform a u substitution. In the remaining term, it's just going to be a tangent squared. So the technique suggested that we apply this power reduction method, and once we've expanded out where we currently are, we repeat as necessary. So repeating as necessary is going to be rewriting this tangent squared as secant squared minus 1. And in the first integral, we're going to go ahead and do a substitution. We are going to let u be equal to tangent so that du is secant squared x dx. So we're going to have our du, and then that first term is going to become a u squared. So the antiderivative of u squared du, so we're going to end up with 1/3 u cubed minus, let's see here, the antiderivative of secant squared is tangent. And then we're going to have minus from out front, but minus the antiderivative of 1 will be minus a minus x plus c. And our last step is to go ahead and resubstitute in. U is equal to tangent of x, and that will allow us to write everything in terms of this original variable. So 1/3 tangent cubed minus tangent plus x plus c.